Okay, now we are starting a new unit, chemical reactions, and these notes start on page 184. I'm going to kind of be bouncing a little bit around, so I'll make sure that I tell you what page I'm on so it's easy to find. So chemical reactions is our next unit. So we're going to do everything from balance to predict what I would make if a chemical reaction occurred. Okay. Now these first two targets we're going to do in class and I'm going to do demos, so we'll be able to talk a little bit about that. But I do want to look at writing chemical reactions in words because this is important and you do need to know how to do this, okay? So it's always essential that we realize that chemical reaction is going to have two aspects. We're going to have the reactants. So what are the things that are reacting together? That's going to be separated by an arrow, which we call a yield sign. And then on the other side of the arrow is going to be the products, or what's being formed. Okay? So I always think about this. The reactants react to produce the products. Okay? And so we always write the names of the reactants to the left of the arrow, separated by plus sign. So if I have more than one reactant, I'm going to put plus to indicate that they're being added together. Okay? And then we're going to write the products on the right side of the arrows, and those will also be separated by plus signs. Okay? So if I look at an example here, I'm not going to ask you to know what hydrogen peroxide is. I would give you its actual covalent naming name. But if I was to write this as a chemical reaction, decomposition of hydrogen peroxide is H2O2. That is the decomposition, meaning I'm only going to start with one thing, and then it says into, meaning it's changing into something else. So I'm going to separate it by an arrow, and it's telling me that I'm creating water, so H2O, and, which is going to be my plus sign, oxygen gas, which is O2. Okay. The other demo that I did in class was the methane gas bubble. And this reaction is of methane gas, which is CH4, and oxygen. Okay? Now, I wouldn't ask you what the products are yet, but eventually you would be able to tell me. But whenever you react this CH substance with oxygen gas, you're going to get CO2 and water. Okay? Which was what I created during class. Okay. So let's go ahead and flip this over. Also within a chemical equation, we can see different symbols being used, okay? And those symbols are as followed. The first three are pretty easy because we have S for solid, and these are going to be subscripts that are going to be past the chemical. So for instance, if I was dealing with something that's solid like gold in my in a equation, it would be gold with an S after it, indicating that is gold solid. Okay, L would be liquid, G would be gas, AQ you might have seen before, you might have not seen before. AQ is aqueous, and what aqueous means is we have a solid that has been dissolved into water. Okay, so something that is solid in standard conditions, so at room temperature and at 1 atmosphere, and we've dissolved it in water, means that it's aqueous, meaning ultimately we could evaporate all of the water and get the solid back again. So aqueous means solid, dissolved in water. Sorry, I'm in the way here. Okay? Heat. Heat is another thing that we can have present in a chemical reaction. And there's two different ways that we can indicate that heat is present in a chemical reaction. The main way that we see it is when we have the arrow separating our reactants from our products, you can draw a triangle above the arrow indicating that heat was present. So in the last lab that we did with magnesium and we introduced oxygen gas, you were heating it over a Bunsen burner, so that indicates that heat is present. Another way that we can indicate it is we could put plus heat as a reactant or plus heat as a product, okay? The other symbol is light, and we indicate that using this HV, which indicates a photon is present, or it's the amount of energy that a photon has, okay? Don't get too caught up on that. I just want you to see it. You probably won't be tested on it. And then the last thing that you can have in a chemical reaction is a catalyst. Now, you may have heard before that a catalyst speeds up reactions. Catalysts do speed up reactions, but they speed up reactions by lowering the amount of energy required for the reaction to start. Okay, and that's how they actually speed up the reactions. So, for instance, hydrogen peroxide, the demo that I did in class, will eventually break down into what we had here, water and oxygen gas. But I added something in it to make it go faster, and I added potassium iodide. So to indicate that something is a catalyst and not actually part of the reaction, we write it above the arrow. So potassium iodide is Ki, which was a catalyst in the hydrogen peroxide reaction. So that's going to be it for this notes part of the section. I do want to talk about and refresh your memory on how to count atoms and molecules. Okay, so I'm going to do a couple of these, and then I want you to actually finish these for homework. So, for instance here, if I look at number one says how many molecules of N2 are shown. So a molecule is more than one atom. So since I have two nitrogen atoms present, it's going to be one molecule. Okay. The next question says how many atoms of N are shown. Well, there's two atoms inside of one molecule. So to indicate nitrogen, or this nitrogen substance here, it's going to be 1 and 2. So this 1 out front represents how many molecules are present, and this 2 represents how many atoms are present. Okay, so let's look at number 2. Number 2 says how many molecules are shown. Well, there's 2 molecules, but there's a total of 4 atoms, right? 1, 2, 3, 4. So I can't have 2 and 4. That doesn't make sense because nitrogen is actually the substance, right? So what I'm going to say is, well, I have 2 molecules, and within each molecule, there's 2 nitrogen atoms. So this would be N2. Now, to get the 4 here, if you remember, the 2 times 2 is going to give me the 4 total nitrogen atoms, and that's exactly what is present here. Okay, now I want you to go ahead and try these other 2 examples that I have present here. In addition to, I would also like for you to try page 199. I'll do the top one for you. Okay? This is talking about the law of conservation of mass. Now we need to remember the law of conservation of mass indicates that matter cannot be created nor destroyed. Meaning, whatever I start with on the reactant side of my chemical equation, I have to end up on my product side of the equation. Okay? So let's look at the first one. The first one says, write this equation out in words. So that's what I'm going to do. I'm going to say I have 4 carbons, so this is going to be tetracarbon, decahydride, and the G represents that it's a gas, and then it says plus, so I'm going to say and oxygen gas, because it's a Hofbrinkel, and you can, for the arrow, you can say make, yields, produces. I'm going to say yields carbon dioxide gas, and water, and you can say water gas, water vapor, it doesn't matter. And the last thing is thermal energy, so I need to make sure that I say and thermal energy. Okay, now it wants me to count atoms, so that's exactly what I'm going to do. So on the reactant side, so on this side of the arrow, it wants me to count carbons. Well, I have 4 of them because of this 4 subscript. I don't have anything out front as a coefficient, so I'm not multiplying anything. How many hydrogens? There's 10. How many oxygens? There's 2. Now I'm going to the product side. How many carbons? There's 1. How many hydrogens? There's 2. Now be careful with oxygen, because I have 2 here and 1 here, so there's going to be 3 total. And then the next question says, is this a chemical reaction or not? And hopefully you're thinking, well, I have destroyed carbon, destroyed hydrogen, and created oxygen. So therefore, this is going to be no, this is not a chemical reaction. And the answer why is because matter was created and destroyed. Or does not abide by a law of conservation of matter. Sorry, I'm trying to write two words together. Okay, so I want you to try those two counting things on the front and number 2, and we'll go over these in class tomorrow. Thank you.